44. So among K positive, Li positive, Re positive, and Cs positive, the number of cations having iconic radii more than Na plus. Okay. So here, so determine the number of cations. Say we need to compare their iconic radii. Ionic radii in general, the ionic radius increases. This is ionic R increases as we move down a group in the periodic table. Okay, so to order the ionic radii for a given, this follows. So like Li less than Na less than K less than this less than Cs. Okay, so from this ranking we can see that there are three equations are there, so therefore the answer is 3. And 46, restriction endonuclease as a recognition site of 3 bases, assuming random arrangement of nucleotides, the probability that the endonuclease will cut a piece of the DNA is what? So the probability we have to, so to calculate the probability of the restriction, what we have to do, we need to consider the probability of the each nucleotide. Okay, so assuming a random arrangement of nucleotides, there are 4 possible nucleotides, so like A, T, G and C. Since the recognition site considers 3 bases, so there are 4 Qs, so total 64 possible combinations of nucleotides. So out of this 64, only one specific combination matches the recognition site sequence, so therefore possibility that the endo nucleus will cut a piece of DNA is, so the possibility that it will cut a piece of DNA is 1 out of 64. So the probability is 1 by 64, 0.016. That's the answer to this question. Next is 47. So a massless ideal spring is hanging vertically. A sphere of mass is around 500 grams suspended from the spring, stretches the spring from the initial position by 50 centimeter when it reaches equilibrium. So the force constant of the spring is what? So the force exerted by the spring can be determined by the Hooke's law. Okay, so this can be expressed in K, F equal to K into X. Okay, F is the force, K is the force constant, and X is the displacement from the equilibrium position. In this case, the sphere mass is 500 and stretches by the 50 centimeter when it reaches equilibrium. So using the Hooke's law, so K F equal to K into 0.5. So we also know that the weight of the sphere is given by mass into gravitational acceleration weight 0.5 here. So into 10 meter per second square 5n. So at equilibrium, the force exerted by spring is equal to the weight of the sphere. So F equal to weight is K cross 0.5 equal to 5. So solving for k equal to 10 n per m. So therefore the force constant is 10. So that's the answer.